Hiya! On today's episode of Bridging Towards 7, we'll have a look at a vectors question from a Singaporean H2 promo exam. Let's look at the diagram. We have a unit circle, right? Unit circle, radius 1. In other words, the magnitude of all of these vectors are 1. With center O and diameter AB. Another thing we can write down right away. B is negative A. They're in the opposite directions because B, O, and A are collinear. By considering an appropriate scalar product, show that AC and BC are perpendicular. Sure, you are asked to consider a scalar product, in other words, a dot product. So, to show that two vectors are perpendicular, their dot product has to be equal to 0. To do this, you then need to express AC and BC in terms of the vectors A, B, and C. So now, let's show this result legitimately. Vector AC, that is OC minus OA. Vector BC, that is OC minus OB. Vector OC, it is vector C. OA, that's vector A. OB, that's vector B. Now we are going to use the properties of dot product to expand this. Vector C times itself, that would be equal to the magnitude of vector C. Recall that vector B is equal to minus vector A. So vector A is equal to minus vector B. These two cancel out. And you're down to the magnitude of C minus the magnitude of B. The magnitude of C is equal to 1. The magnitude of B is also equal to 1. The reason that they are all unit vectors, because they are vectors on a unit circle. Therefore, this product is equal to 0, and we can then conclude that AC and BC are perpendicular. We'll skip part B because it's not part of the syllabus. Moving on to part C. In part C, we are asked to show that C, M, and R are collinear. And we can either consider the cross product and show that it is equal to 0, or alternatively, we just have to show that CR is equal to a constant multiple of CM, and both vectors contain C. I would personally go down this path instead of taking the cross product, simply because there's no real benefit to taking the cross product in this case. So, let's now express CR and CM in terms of A, B, and C. ABCD is a parallelogram. So, we need to use this fact somehow. First, we need to find CR. How can we find CR? CR, that is equal to BR minus BC. We know that OA divided by AR is 1 by 2. That means OA is equal to A, so AR is equal to 2A. BR is therefore equal to 4A. Notice that B goes in this direction, so A goes in the opposite. BC. BC, that is OC minus OB. OB, that is negative A. And we'll get 3A minus C. Let's now have a look at CM. How can we find CM in terms of A and C? We know that M is the midpoint of AD. We also know that ABCD is a parallelogram. This infers that AM is equal to a half of AD and is equal to a half of BC. CM is therefore CA plus AM. CA, that is OA minus OC. AM, that is a half of BC. OA, OC, OC, OB. B is equal to minus A. As we can see, CM is exactly equal to a half of CR. Furthermore, C is the common point of the two vectors. Therefore, C, M, and R are collinear. For the alternative method, you would express Cm and Cr in terms of A and C like we just did. And then you are going to take a cross product. I do not understand why you would do that, considering that you can just conclude and finish the question right here. I hope you enjoyed this explanation, and I will see you in the next one.